So in the data table, you can see that we used equal masses of water in the calorimeter for each experiment, as well as equal masses of food samples, 10 grams for each. One significant difference worth noting is that the temperature of the room, as detected by the Vernier probe, was 0.7 degrees Celsius higher when we tested the flax seeds, and that was probably a factor in the 32.3% error, according to the literature value. That said, the test for the pasta, the carb, returned results of 16.9 joules per gram, which is remarkably close to the literature value of 16.8 joules per gram. The units in this experiment were absolutely crucial, as the equation of Q equals mc delta T is only accurate when the units cancel out, which leaves behind joules divided by grams. Hence, the final unit of measurement for the energy content of food is joules per gram. The final results for each macronutrient were for the carbohydrates, Q came out to equal 16.9 joules per gram, and for the fat, Q equaled 25.6 joules per gram. It's important to consider when you're reading the results that Q is only a measurement of the thermal energy absorbed by the water in the calorimeter, and is thus not directly the energy content of the food. The energy content of the food, however, could roughly be calculated by dividing the heat change of this food sample itself while burning by the mass of the sample. This isn't possible using the calorimeter method, however. It's clear from the calculations that our sample for fat, flaxseed, did not meet the literature value for the joules of energy in a gram of fat. That said, the energy content of a carb was still lower than that of a fat, which is consistent with our literature values.